so that we can all wonder at the universe a little bit together. And I want to start our story today in 1846, because 1846, let's see if my clicker, look at that. 1846 saw one of the landmark moments in the history of science. The French mathematician Leverrier was studying the orbital motion of the planet Uranus, which had been discovered like less than 60 years earlier. And he was sort of noodling on a problem that astronomers had discovered, which is that the orbit of Uranus does not match what Newton's fancy laws of gravity say that it should. It just wasn't lining up right, and nobody could really figure out why. So Leverrier was thinking about this, and he finally one day had one of those like light bulb moments and realized all of this makes sense if and only if there's another planet, an eighth planet, that must be farther from the sun and bigger than Uranus. So using all those fancy physics equations, he calculated where that planet must be and how big, how massive it should be. And then he wrote a letter to one of his friends, a guy named Johann Galilei, a German astronomer. And on the very night that Galilei received that letter, he went down the street to the Berlin Observatory, pointed the telescope to where Leverrier had calculated, and bam, there was Neptune. And it was a sensation. The idea that somebody halfway across the continent, playing around with pencils and paper, could find a planet and tell someone where it was who had never seen it before was a revelation. It was one of these sort of fundamental proofs that physics and this new field of astrophysics actually works. And as a side note, as an astronomer, nobody has ever mailed me a life-changing discovery and just said, hey, check this out tonight. So, all the good discoveries have really been taken. And this kind of, ruined it for the rest of us. But let's jump forward 175 years to the launch of the James Webb Space Telescope. You can see the model of the telescope here, surrounded by a very small part of the people who worked on this project. Before the thing even launched, hundreds, probably thousands of people worked on it. Scientists, engineers, technicians, the guy that drew the little logo, all these important roles to get this thing into space. And then over the next decade or so, hundreds of astronomers are going to use James Webb to revolutionize what we understand about the universe. But the question is all of this really going to make a discovery like this? Right? How did a couple of guys writing letters back and forth become hundreds or thousands of people creating the technology needed to look farther into the universe? And claim tonight is that we can blame all of this on one guy, this sucker here. And this is supposed to be our Valentine's Day Astronomy on Tap. And so I want to give my Valentine this evening to George Ellery Hale, because more than anyone else in the history of astronomy, he brought the modern world of astronomy that we have today. And he did that because he had a singular obsession. He loved building big-ass telescopes. And over the course of a 40-year career, he would build the world's largest telescope 4 times. And along the way, he would take us from an astronomy that was just a couple of guys who were pen pals to the massive scale exploration that we enjoy and endeavor in today. And so for Hale, this story really started in 1897 at the Yerkes Observatory, where he was newly made director. This is north of Chicago, run by the University of Chicago. And he was overseeing the creation and installation of the largest refracting telescope ever built. You can see a picture of it here on the right. Now, a refracting telescope just means it works like a spyglass, where you look down through it and a big lens reflects the light into your eyes. 40 inches across, and you can see how big it is. There's a guy right down there. Here's the telescope. Looks like a giant spyglass just scaled up. And in fact, this wouldn't just be the largest refracting telescope ever built. It's the largest one that could ever be built. Because it turns out that the properties of glass are such that if you try to make a lens bigger than 40 inches, it just sags out of shape and it won't focus the light. So this was it. This was the pinnacle of the technology of refracting telescopes. And Yerkes, in a way, was the pinnacle of the old way of doing astronomy. This way where you'd eat dinner at home, then walk down the street and use the telescope in the observatory at night. And so Yerkes was kind of the turning point. And it also served as the turning point into the 20th century for American astronomy, because we got folks like these who did their earliest work here at Yerkes. And you know, you got kind of heavy hitters. It's like, this guy's a telescope, and this guy's a telescope. She's going to be a telescope in a couple of years. And poor Kuiper has to just sort of satisfy himself with having a whole part of the solar system named after him. Really slumming it, but we'll give him his due. But while these guys were doing their thing here at Yerkes, Hale had moved on to thinking about a new kind of telescope and a new kind of observatory. He was going to build a reflecting telescope, which uses a mirror instead of a lens, to make things even bigger. Now, he certainly didn't invent reflecting telescopes. They dated all the way back to Isaac Newton a couple of centuries earlier. But no one had really successfully used them to do professional astronomy because there were some problems to solve. And so Hale set out to solve those problems, and at the same time, he set out to create a new kind of observatory at the same time. Because this kind of observatory is convenient, right? You eat dinner with your family, then go do your observing. But naturally, that means that they're not always in the best places. They're in places like the center of Berlin, or the suburbs of Chicago. You're not famous for the world's best places to look up and see the night sky. And so he thought, okay, we're going to create a new kind of telescope, and we're going to put it not where it's convenient for people, but where it's the best place to see the sky. We're going to look for the place with the least light pollution. We're going to look for the clearest, stillest air to make sure we have the best view of the sky. And so he searched the whole United States looking for the very best place, the cleanest, clearest place to look at the sky. And he came to the conclusion there's only one place that meets those criteria. And of course, it's Los Angeles. What could be clearer than this? But of course you have to remember the year is 1900. LA doesn't really look like this, but it's more than that, because the same effects of the atmosphere that trap all of this smog here make the sky up here some of the clearest and cleanest anywhere in the United States, even today. The trick is to take advantage of that. You can't build your telescope here. You've got to build it up here. And so he finally locates a site on a mountain called Mount Wilson and sets forth to construct his observatory. And this is something like out of Greek mythology, because it's days to get from here to here, and you've got to do it on the back of a donkey with everything that you want to take up there. You know, imagine dragging the world's largest telescope up the hill on the side of a cliff on the back of a donkey. It took years to get all that stuff up here. And then you got to start building the observatory. But as this work happened, it also meant that you had to have new help, right? You couldn't just eat lunch with your family and head to the observatory. You had to have cooks and cleaners and people who could repair things, people who could operate the telescope. Because here you are, days from civilization. It's not just something you do in your spare time. And so we see the beginnings of the sort of professionalization of all of these roles around that of the astronomer. The first buildings of these support structures that will eventually help put the James Webb into space. So you can see the 60-inch here on the left, and Hale had sort of one more addition to this telescope, which was that it was going to make one more sort of leap and embrace this cutting-edge new technology of photography. No more were people going to look through the telescope and sketch what they saw. If that was the case, I would never be an astronomer. And instead, they were going to take some photographs. This is one of the first photographs taken by this 60-inch telescope built at Mount Wilson. And this is just leaps and bounds above what you could do when you were sketching. But for Hale, this wasn't enough. The astronomers got to work using this. It was an amazing tool, discovery after discovery. But Hale said, you know what's better than a 60-inch telescope? A 100-inch telescope. And so just 9 years after building the largest telescope in the world, he did it again. And just look at it. It's a thing of beauty. It's just this combination of engineering and art, and it's timeless. It's also one of the 2 or 3 most important telescopes in the history of astronomy, because within just the first 20 years of operation here at Mount Wilson, this 100-inch telescope made 3 of the foundational discoveries of the 20th century. Number 1, it proved irrevocably that there's more than just the Milky Way out there, that there are other galaxies. So suddenly we aren't just living in the Milky Way, we're living in a universe full of galaxies. That's the beer talking. Then number 2, it showed that that universe isn't just vast, it's getting bigger. And if you wind back time on something that's getting bigger, it shrinks down to something we today call a Big Bang. And then number 3, this telescope provided the very first evidence for what we today call dark matter. This mysterious substance that's everywhere in the universe, but we can't see it. There's more dark matter out there, much more, than all of the mass, all the stars and planets and galaxies that we can see. We still today don't know what it is. James Webb's going to help us search for its origin, but we first found it here at the 100-inch on Mount Wilson. So these guys, like Mr. Hubble here, were doing this work, but Hale had already moved on. Because you know what's better than a 100-inch telescope? A 200-inch telescope. This was going to be, yeah, that's right. This was going to be just a monumental undertaking. I mean, look at this thing, the size of the mirror. This, to this day, remains the single largest piece of glass ever turned into a single mirror. And here Hale started to run into sort of the trouble with the first half of the 20th century. This project was first delayed by the Great Depression, then by the outbreak of World War II, wasn't actually completed until 1949, at which point Hale had died. And so we never saw the completion of sort of his greatest triumph. But today we call this the 200-inch telescope, the 200-inch Hale telescope at Mount Palomar outside of San Diego. And I was just talking to colleagues before the talk, and there are people in this room who have observed on this telescope, done science here, because to this day, it remains an important astronomical tool. And it was the largest telescope in the world, and the largest telescope in the outside the Soviet Union till the end of the 20th century. So if we count this back from 1897 until 1999, Hale had built the 4 largest telescopes in the world that were the biggest and most important tools for a century. And this guy never actually even used them. He was a solar astronomer. He went out during the day and looked at the sun. Buy some solar eclipse glasses, and you can see what he was all about. He was the first person to actually tell us what creates sunspots. He was an active researcher in a field totally separate than all of this stuff we were just talking about. But he had this vision that to take the next step, to make the next generation of discoveries, it was going to take not just more tools, but more people to get it done. And I think more than anything, he took us from astronomy as a pastime of the rich guys living in castles in Europe to the sorts of endeavors that people like me, people like some of our other speakers can do. So, happy belated Valentine's Day to George Ellery Hale. He brought us astronomy as we know it today, and to him I say thank you.